Assalamu alaikum warahmatullah. Now I discuss with you the shortest path problem. Here you see problems. Now we solve this problem. We consider A is the source vertex. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 vertex, 8 vertices. We can consider uh, any we can consider any vertex as source vertex. Now here we consider A is source vertex. If you want to consider B, C, D, E, F, any other vertex as a source vertex, no problem. So now we started. The main formula of this problems is if the distance of u plus cost of uv less than distance of v, then set distance if distance of u plus cost of uv less than distance of v, then set distance of v equals to distance of u plus cost of uv. It's the main formula of this problem. Here A is a source vertex. At first we select source vertex add to A equals to 0. All other vertex are distance are infinity. Infinity. Okay, then we can visit B and C. If we want to visit A to V, we can consider A as U and V as V. U and V as V. Then the distance of U equals to 0, distance of V equals to 4. Cost of U and V equals to 4. Again we can say that distance of A equals to 0, cost of A to B equals to 4. We can write like that: distance of A equals to 0, cost of A B equals to 4. Okay, distance of A equals to 0, distance of cost of AB equals to 4. Then cost of 0, cost of 4 equals to cost of 0, distance of A plus cost of A B, distance of 0 equals to the distance of A equals to 0, cost of AB equals to 4, AB equals to 4, that is less than distance of V equals to infinity, less than infinity. So we can write distance of B equals to distance of B equals to distance of A plus cost of A B. So 0 plus 4 equals to 4. So distance of B equals to 4. Here the value, the distance of V equals to infinity, the distance of 4 equals to, and we get distance of B equals to 4, distance of 4 less than infinity, so we can update the distance of V equals to 4. Then we can also visit C and distance of A equals to 0, cost of A equals to A to C equals to 3. So the distance of A plus cost of A to C less than cost of C, distance of C. Then distance of A equals to 0, cost of AC equals to 3. Cost of AC equals to 3 less than distance of C equals to infinity. So we can write that distance of C equals to 0 plus 3 equals to 3. We get the distance of C equals to 3, that is less than distance of C. So we can update the distance of C as 3. Now we can select A already selected. Here the remaining vertices C, B, D, E, F, G, Z. The distance value of remaining vertices smallest distance is C. So C is selected. Now we visit, from C, now we visit C to E, C to B, C to D. So at first we visit C to B. C to B. Here the distance of C equals to 3, and the cost of B equals to 2. So the summation of distance of C plus cost of CB equals to 3 plus 2 equals to 5, that is greater than 4. So the distance of B don't need to update, so it's remaining. And then we can visit A to D. Here the distance of C equals to 3 and the cost of A to D equals to 3. So the summation of so the summation of the distance of C and the cost of CD equals to 3 plus 3 equals to 6, that is less than infinity, so the value is updated. So the value is updated. We can write 3 plus 3 equals to 6. Again we can visit C to E. Here the distance of C equals to 3 and the cost of C to E equals to 6. The summation of distance of C and the cost of CE equals to 6 equals to 3 plus 6 equals to 9, that is less than infinity, so the data is updated. Now the remaining data except A and C, because they are already selected, the smallest value of remaining vertices, the smallest distance of remaining vertices are B. So B is selected. From C we can visit D, C, B to D, B to C, but we can't visit B to C because C is already selected. So we can go B to D. Here the distance of B equals to 4, the cost of BD equals to 5, so the summation of so distance of B plus cost of BD equals to 4 plus 5 equals to 9, which is greater than 6, so the value does not so the distance of D need not change, need not update. B is completed. Then the remaining vertices is D, E, F, G, Z. Which distance is smallest? Obviously D. So D is selected because the among the remaining vertices, D is smallest. So from D we can visit E, F. So we can visit E. The distance of D equals to 6 and the cost of DE equals to 1, so the value is 6 plus 1 equals to 7. 7 is less than 9, so the distance is updated. So the distance is updated. Now we can visit D to F. The distance of D equals to 6, the cost of DF equals to 5, so the value is 6 plus 5 equals to 11, which is less than the distance of F, so the value is updated. D is completed. Now we can among the remaining vertices, 7 is smallest, so E is selected. 7. now from E we can visit only G and C and D, but we can't visit C and D because they are already selected. Now we can visit E to G. The distance of E equals to 7. The cost of E to G equals to 5. G equals to 5. So the distance of E plus the cost of EG 5 plus 7 equals to 12, which is less than infinity. So the data is updated 12. Then E is completed. Now the among the remaining vertices F is smallest, so F is selected. Now from F we can visit G and Z. G and Z. Z is so we at first visit Z F to Z. So the distance of F equals to 11. The distance the cost of F to G equals to 2. So the value is 11 plus 2 equals to 13. 13 is greater than 12. So 12 need not update it. So the distance of G need not update it. Then we can go Z. We can visit F to Z. The distance of F equals to 11. The distance of F equals to 11. The distance of Z equals to the distance of the cost of F to Z equals to 7. So 11 plus 7 equals to 18. 18 is greater than the distance of Z infinity. So the distance of Z is updated 18. Okay, then F is completed. Now among the between the two remaining vertex G and Z, Z is smallest, so Z is selected. Now we can visit from Z we can visit E, F and Z. E, F already selected, so we can only visit Z. The distance of Z equals to 12. The cost of Z to Z equals to 4. So the value of Z equals to so the value of is 11 12 plus 4 equals to 16, which is less than 18. So the distance of Z equals is updated 16. Okay, now G is completed. Only one vertex are remaining, so Z is selected, but we can't visit any vertex because all the vertexes are G and F already visited, so already selected. So Z is completed. The value of Z is remaining. So we complete our shorted path. Now we calculate our shorted path. Now we find out the path, so node distance previous. Follow me. ABC. Now we write the node of the graph A B C D E F G Z. The distance of A equals to 0, the distance of A equals to 0, the distance of B equals to 4, the distance of C equals to 3, the distance of D equals to 6, the distance of E equals to 7, the distance of F equals to 11, the distance of G equals to 12, the distance of Z equals to 16. These are final distance. The previous node of A equals to nothing. The previous node of B equals to A. The previous node of A equals to C equals to A. The previous node of D equals to D value distance হচ্ছে 6, তাহলে 3 A SC CD, তাহলে কোন পাথ হচ্ছে এটা, তাহলে previous হচ্ছে D এর the previous of D equals to C, the previous of E equals to 6 plus 1 7, that means D. The previous of F equals to 11, the value of 11, 6 5 11, that means A C D E, that means the previous of F equals to D. The previous of G equals to 12, how can we get 12? That means A C D E G 3 3 1 5 7 5 9. So the previous value is E. The previous node is E. The previous node of Z equals to G, because 4 plus 12 plus 4 equals to 16. G. So now we write without the starting the source vertex, we write all vertices S C D E F G Z. Now the previous vertex of B equals to A, the previous vertex C equals to A, the previous vertex of D equals to C. C is not the source vertex, so that the previous vertex of C equals to A. The previous vertex of E equals to D. so D is not a previous vertex, source vertex, so the previous vertex of D equals to C, the previous vertex of C equals to A. A is a source vertex, so we don't go ahead. Now the next, the previous node of F equals to the previous node of F equals to D, the previous node of D equals to C, C equals to C A. The previous node of G equals to the previous node of G equals to E. The previous node of E equals to D, the previous node of D equals to C, the previous node of C equals to A. The previous node of Z equals to Z, the previous node of Z equals to E, the previous node of E equals to D to A. Okay, these all are our short vertices. The value of A to F, তারপর হলো A to D, তারপরে the length of path is A to D, A to F, তারপর হচ্ছে B to F, B to Z, C to F, C to F, B to Z. Here A to D হলো third path A to D at 0, C3 as 0, তাহলে এটার জন্য A plus C plus distance of A plus C plus distance of D. তাহলে distance of A equals to 0, distance of C equals to 3, distance of D equals to 6 equals to 9.